Our objective for today, I can factor quadratic trinomials. Read together. 1, 2, 3. I can factor quadratic trinomials. So today we're moving on, and like I said, today's going to be a day that we're going to have a couple things being presented. And like I always, when we move on to a new concept, I like to start off by introducing the concept in a different manner. So before we move on, I'm going to have you think or get a prayer model first, ready for quadratic trinomial. And as you're writing quadratic trinomial in the center, start thinking, what would be a good definition for a quadratic trinomial? Don't say it out loud and don't write it on your paper. Just think about it. What would be a good definition for a quadratic trinomial? Okay, I'm going to send you a screen on your iPad so that you can write what you think would be a good definition for a quadratic trinomial. I don't want any examples, I just want a definition. What would be a good definition for a quadratic trinomial? I'll pause this really quick. So I wrote on mine something similar. It should be on your screen. An expression of 3 terms with the highest degree of 2. Very similar, yes? Examples, write this down. Example, I'm going to write x squared plus 2x plus 1. I'm also going to write 2x squared plus 6x plus 5. Those are examples of a quadratic trinomial. Let's see. Does it have 3 terms? 1, 2, 3. Yes. What is the highest degree? 2. Does it have 3 terms? 1, 2, 3. Highest degree is 2. Okay. So, with that said, write a non-example. What would be a non-example? Okay, now that you have your example, non-example, what would be a hashtag that you would send someone for this pick? Hashtag what? Don't say it out loud, just write it in. Hashtag, hashtag. Alright, share with your neighbor your non-example and one of the hashtags at least. Go. Okay, non-example. Let's see. Reagan, what would be your non-example? X to the second. And if you agree that's not a quadratic trinomial. Okay? Tell your neighbor the name of this one, please. Who said quadratic monomial? Because there's only one term, yes? Okay? So, hashtag. What'd you get for hashtag? Esmeralda. 3 terms. How about another? Samantha? Highest degree 2. Alright? So we good up to right there? Alright? So from there, underneath that, I want you to write steps. And you're going to come up with the steps because we're already in second semester. So just look at the process that we're going to do and come up with a good couple of steps, maybe 2 to 3 steps that you can follow for the process that I'm going to show you. Now, 2 things I'm going to show you today. One of them is how to approach it with the area model. And another way is a new method that I'm going to show you today towards the end. But for right now, I want to revisit what we started in the first semester with algebra tiles. So, right now on your desk, I want you to get the baggie of algebra tiles. Get those out. You're going to need some space on your desk, so if you have anything else that is not the iPad or your paper or notebook that you're taking notes, put it on the side. Let me get my camera ready. Alright. So, let's see if we remember what we have in front of us. So, for right now, you got them all together, right? So this is what I want you to get in front of you. I want you to get in front of you the following polynomial. Ready? I want you to show me x squared plus 3x plus 2. X squared plus 3x plus 2 using tiles. Show me that in front of you, please. Okay.
I don't know what it was.
No, so right now just show me that. Your neighbor's going to see it. Okay? Alright, look at your neighbor's polynomial, see if they have that in front of you like yours. Alright, let's see. Let me show you with mine. See if you have something like this. Look up. 1 big square, 3 rectangles, and 2 yellow. So what do we have in front of us? X squared plus 3x plus 2. Are we there so far? Okay, next. With those same tiles that we have in front of us, these. Pay attention to this part. I want you to put them together and make a square or a rectangle. But the key, keep all the yellow ones together. Go. Once again, put this puzzle together to make a rectangle or a square, but keep all the yellow ones together. Go. I'll give you some time. Alright? So I'm going to go with this one that looks like this. Alright? So check this out. Write your pencils down, look up to the screen. There we go. I'm going to factor this polynomial completely using the area model. So write your pencils down, look up to the screen. Here I go. So I'm going to call this example Q. Oh, you can barely see it. Okay, sorry. Example Q. Alright. So what did I start with? I started with x squared plus 3x plus 2. And we need to come up with 2 factors. Julian, focus. My goodness. So what are my 2 factors? Well, let me figure this out. First of all, what is this one again? X squared. How many x's are here? 2x. How many x's here? 1x. How many 1's are here? 2. So check this out. If this is x squared, that means this side times this side gives me x squared. Is that correct? So what does this side measure then? And x. Question. X times what gives me 2x? X times what gives me 1x? Or in other words, look, what is the measurement of this little piece right here? 1 plus 1 is 2. This one is 1. So my factors are x plus 2, x plus 1. Factors. I know, right? Let me show you how it looks like if you were to draw the picture of what you see. Check this out. The picture should look something like this. X squared, 2x, x, 2, x, x, plus 2, plus 1, and these are my factors. Copy that, please. That's example Q. I know, right? Let's go. From the corner. Copy that. Hurry up, hurry up, hurry up. No, just the what's on the screen. Alright, here we go. Once you're done copying that, underneath that you're going to write example supercube. And I want you to get in front of you x squared plus 5x plus 6 with your tile. Make it into a rectangle. Once again, keep the yellow ones together. And find me the factors. I'll give you some time. Copy that and go. Alright, so this is what you have. I'm going to use this one. Oh, let me, okay, there it is. And so what did we start it with? We started with x squared plus 5x plus 6. Is that correct? Yes. And our factors are, let's see if you got it. We know that this is x squared, therefore this is x and x. So far so good? Yes. Plus, what makes this piece right here? This is 3 x's, this is 2 x's, and this is 6. X times what gives me 3x? 3. X times what gives me 2x? 2. So my factors are x plus 3, x plus 2, or x plus 2 times x plus 3. What property allows us to move these around? Commutative property of multiplication, right? We can move them around, okay? Hands if you got that? Okay, good? Alright, one last one. I want you to get in front of you 1x squared plus 2x plus 1. Make a figure out of that. X, I know. That's what I'm telling you what to get. X squared plus 2x plus 1. X squared plus 2x plus 1. No. Just factor it. Let me see. Let me tell you what I have. There it is. Let's go. No, not that figure. You're going to make a square or a rectangle, right? No, they're dabbing. Let's go. Alright, so let's see. Did you do something like this? Hands if you got something like that. Okay, good. Therefore, let's see. We started off with x squared plus 2x plus 1, and my factors are, everyone? X plus 1 and x plus 1. What's another way of writing x plus 1 times x plus 1?
X plus 1, x plus
to the second power. That is correct. Let's go. You got this, yes? Okay, so that was factoring using the error amount. Now we're going to move on to factoring using algebra. Yay! Let me pause this for Q. Example Q. Copy that, please. It says, factor each trinomial, check your answer. X squared plus 15x plus 36. Yes. No, hold on. Once again, example Q says, factor each trinomial, check your answer, x squared plus 15x plus 36. Alright, so this method, and I'm about to show you, I call it the Power Rangers. It's still factored by grouping, but there's a step. Remember Power Rangers when they used to, right before they used to go battle, they used to do this, right? Right? So, I'm going to draw an X to get started, and then from there, we're going to go into factor by grouping. So, writing pencils down, look up to the screen. Here we go. Two things that I check for. Is it in standard form? Yes. Is there a GCF other than 1? No. Once I check that, I draw my power rangers over here. So check this out. Writing utensils down, you're just paying attention. So watch. I'm going to write the last term on top. I'm going to write a multiplication sign. The middle term on the bottom. And I'm going to write a plus sign. What does that mean? That I need to find two numbers that when you multiply them give us 36, but when you add them give us 15. So how do I start? I need to start with the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Which of those pairs adds up to give me 15? Everyone. 3 times 12. Yeah, 4 and 9 are only 13, and this is 15, right? Okay, so you're just paying attention right now. Yes? Here we go. I'm going to rewrite this trinomial by bringing down the first term, the last term. However, this one became now this. So instead of writing 15x, what am I going to write? 3x plus 12x. Do you agree that these 15 became 3 and 12? Yes. If that's true, that means at this point I can use factor by grouping. What is GCF for these two? X, we're left with x plus 3 plus, what is GCF for these two? 12. What do you have left? X plus 3. So my factors are x plus 3 times x plus 12. These are my factors. However, it says check. How do we check? Well, guess what? Using the area model. X plus 3 times x plus 12. Let's see. What is x times x? X squared. What is x times 12? 12x. What is 3 times x? 3x. And 3 times 12 is 36. Let's see. X squared plus, so my peanut, 3 plus 12 is 15x. Bring down the plus 36. Did I end up with what I started with over here? Check. Copy that, please. Let's go. I know, that's why I said you guys need to stay focused because this is like part time. Let's go. Hey, that's a good idea, Isaac. Partay. Once you're done with that, copy example super Q. X squared plus 5x plus 6, and I want you to factor it using this method. Some people call it the diamond, some people call it the X, I call it the Power Ranger, and then from there with grouping. Copy that and go. Okay, I'm going to move on to example super Q. Let's see if we follow along. What do we check first? To see if it's in standard form or GCF. Standard form, yes. GCF other than 1, no. From there, what goes on top? The last term, which is 6. You make that our product. What goes on the bottom? The middle term, and that becomes our sum. What are the factors of 6? 1 times 6, 2 times 3. Which one of those adds up to 5? 2 and 3. Therefore, we rewrite our polynomial. X squared. Instead of 5x, what do I write, everyone? 2x plus 3x. And then you bring down the last term. Does everybody know where I got 2x and 3x? Yes. And therefore, at this point, we group. GCF here is x. We're left with x plus 2. GCF here is 3. We're left with x plus 2. My factors are x plus 2 times x plus 3. These are my factors. Do we know how to check? Using what? Area model. Home plate for tonight is on page 539 only. There is tutoring. If I don't see you guys tomorrow. Bye.